You guys can see now, right, on virtual? You should be able to. Okay. So this is lesson 3.3. Somebody grab that, which is dividing polynomials using synthetic division. And like I said, if you're in class, this is the packet you already have. If you're on virtual, it's in module 3.3. So these are the steps for synthetic division. I'm not going to go ahead and read out all these steps because I'm just going to show you them. But this is a good reference point if you get stuck at home or you forget how the steps go, to look back to these steps and reference them and figure out what's going on. So what's important out of these steps, though, is the format in which you write your final answer, which is identical to how you write your final answer when you do long division. It's always the quotient plus the remainder over the divisor. Now, can anybody remind me, if your remainder is 0, do you need to write the remainder over divisor part? No, because anything divided by 0, or sorry, anything dividing into 0 is just 0. Anything 0 in the denominator is bad news, but that's not the case here. Numerator is okay. So let's talk about how to do synthetic division and what synthetic division is. So synthetic division is a method that allows us to more quickly do long division with polynomials. Okay, so it's basically a faster way to do what we had learned about in the previous lesson 3.2. However, it does have its limitations. Synthetic division is only useful when you're dividing by a binomial where the coefficient in front of the x, a linear binomial where the coefficient in front of the x is 1. So you guys see how in this denominator here, this is a linear binomial, x to the first power, 2 terms, and the coefficient in front of the x is 1. See that? That's the only time that you can use synthetic division in that case. Okay, you can't use synthetic division when you're dividing by something that's like x squared or anything like that. It only works when you have like x plus 3, x minus 5, something like that. So let's talk about how you do synthetic division. So you have this sideways L shape, okay, like this, and you always draw one of these, okay? It's basically an upside down division symbol that we use to do regular long division. What you put on the outside here is, see how we have x plus 3? You're going to put in what makes x 0, which would be the opposite sign of positive 3, which would be a? Good. So a negative 3 is what goes right here. Okay, it's the opposite sign of whatever you have x added or subtracted from your denominator. Any questions about that part? Okay, so then up here is where you list the coefficients of your dividend, your numerator. Now, just like with regular long division, you need to put in a placeholder term if you're missing any of the x's. So if I go through this, I have x to the 4th, and then I jump to x to the 2nd. So which x term am I missing? X to the 3rd. So see how I'm missing x to the 3rd? You need to put in a placeholder term here, 0x cubed. So anytime you're jumping from x to the 4th to x to the 2nd or anything like that, you're jumping an x, you need to put in a placeholder term, just like with regular long division. Do we have any questions about the placeholder term? All right, so then you're going to use the coefficients of your polynomial to do synthetic division. So you're going to write the coefficients of them right up here. So what's the coefficient of x to the 4th power in this case? 1. That's what you're going to write right here. What's the coefficient of the x cubed? 0. What's the coefficient of the x squared? Negative 10. What's the coefficient of the x? And what's the coefficient of the, well, sorry, basically the coefficient of the x to the 0, which is your constant, which is just 4. So that's how you set up your synthetic division. Any questions so far? Now, the first term, okay, the first number in your synthetic division, you just drop it down. You don't do anything with it, you just drop it down outside here, okay? Once you drop down that term, you're then going to multiply what you brought down times your divisor here. What's negative 3 times 1? Negative 3, that's what goes in this circle right here. Then, instead of like long division, instead of subtracting, you actually are going to add these. You're going to combine these terms vertically. So what's 0 plus a negative 3? Negative 3 goes right here. Now you're going to repeat the process. Negative 3 times negative 3, you multiply here, is positive 9. You're going to add these. What's negative 10 plus 9? Negative 1 goes right here. Then you multiply. What's negative 3 times negative 1? 3 goes right here. Then we add. What's negative 2 plus 3? Positive 1. We do it again. Negative 3 times 1. Negative 3 goes here. And we combine and we get 1. So was everybody able to follow the process we did there? And we'll do another practice problem so you can get the hang of it. So now I want to talk about what all these numbers mean. Okay? So the first, or the one all the way to the right that you get, the result, that's always your remainder. Okay, the one furthest to the right is always your remainder. Now, all of these other numbers actually represent coefficients of your x terms. So how you figure out what those are, it always goes constant, which is the one directly to the left of the coefficient. So this is the constant. This is the coefficient of the x. This is the coefficient of the x squared term. And this is the coefficient of the x cubed term. And sometimes you're going to have more terms here if you had longer synthetic division. And it just keeps going. X to the 4th, x to the 5th, x to the 6th. You guys get the idea here how that goes. So how you write out your answer? This is the x to the 3rd, coefficient of x to the 3rd, which is 1. So it's just x to the 3rd. This is the coefficient of x squared, so negative 3x squared. This is the coefficient of the x, which is just negative x, negative 1x. And then the last one, the one closest to your remainder, is always your constant term. So that's how you write out your quotient. Your quotient is the result of the synthetic division. And your final answer, you write just like you write with regular long division. You write out your quotient. And it's always the quotient plus the remainder over the divisor, your whole divisor, which is x plus 3. And that is your final answer. So just to make sure this is clear to everybody, anything that you solve with synthetic division can be solved with long division. But not everything you solve with long division can be done with synthetic division. Does that make sense? Okay. Does anybody have any questions about any of these terms? And James, I can go back to this slide for you at the end.
It's online too, right?
It is, yep.
Okay.
I'm recording it right now. Okay, so let's go ahead and do this one here. So we set up our synthetic division by doing an upside down sideways L like this. Okay, go ahead and write one of those. Now we have to look at if what we're dividing by is a linear binomial with a coefficient of 1. Is this a linear binomial with a coefficient of 1 on the x? Yes. Once you get that, you're going to take the opposite sign of whatever this is, which is negative 3. Your negative 3 goes right here. That's from this right here. Now you're looking at your dividend. And we're looking to see if we're skipping any x's. We go x to the 3rd, x to the 2nd, x to the 1st, and the constant. Did we skip anything in this one? No, so we don't have to add any placeholder terms in. Now up here, you're going to write the coefficients of all of those x's. So it's going to be 2. What's the next one? 3, negative 4, and 15. Very good. So now we're going to go ahead and do our synthetic division. So for the first one, you always just bring it down. You don't have to do anything with it. Now you're going to start multiplying. So what's negative 3 times 2? Negative 6 goes here. Then we're going to add them. What's 3 plus negative 6? Negative 3. Remember, you're adding these, okay? These are all addition. Then you're going to multiply. Negative 3 times negative 3 is 9. You're going to add. What's negative 4 plus 9? Positive 5. And lastly, negative 3 times 5 is negative 15. We add these together. What's 15 plus negative 15? 0. So in this case, my remainder is, good, my remainder is 0. So sometimes you'll see your remainder like written off in a little box like that, just so you know. And your remainder is 0. What did we learn about the fact that when your remainder is 0? That means that the result is a what of the dividend? If I divide 6 into 42, it goes in evenly, right? 7 times. So both 6 and 7 are what of 42? Factors of 42. So let's write out our answer. So this is your constant. So this is x term and x squared. So this is going to be 2x squared minus 3x plus 5. Now you also have to add your remainder over your divisor, but in this case my remainder is 0, so do I need to do that? No. So whenever my remainder is 0, that means that both your divisor and your quotient are what to the dividend? Factors. They're both factors of this. So when you get a remainder of 0, your dividend, or I'm sorry, your divisor and your quotient are both factors of your dividend. Meaning that you could factor your dividend into these two polynomials. So that's what that means. So what this really means when you do this division, it means that 2x squared minus 3x plus 5 times x plus 3 is equal to this. Because multiplication reverses division, right? So you guys starting to make all the connections here on this, or is it starting to make sense? This, no, I'm just trying to show you how, like, when you divide by it, you could get it back by multiplying by your answer. That's all. You don't have to write that. All right, let's go ahead and try the next one together. So I'm going to draw my synthetic division symbol here. And I have to check and see if my divisor is a linear binomial with a coefficient of 1. Is it?
Yes.
Yes. And what am I going to put out here?
Positive 2.
Positive 2. Does everybody understand why the 2 is positive? It always changes sign, okay? Now we're going to write the coefficients of my dividend terms. So are we skipping any x's in these dividend terms?
No.
No. So we can write 3, negative 8, 11, and negative 14 out. We're going to bring down the 3. What's our next step after this? Good, we're going to multiply. 2 times 3 is 6. We're going to add. What's this become? Good, then we're going to multiply. What's 2 times negative 2? We're going to add. What's 11 plus a negative 4?
7.
Good, then we're going to multiply. What's 2 times 7?
14.
And then when I add at the end, I get? So my remainder in this case is 0, which means that my divisor and my quotient are both what to my dividend? Factors. Very good. When there's no remainder, or the remainder is 0 rather, we don't have to write the plus part, we just write 3x squared minus 2x plus 7. Make sense? And if you did this with long division, your answer would be the same, as long as you did it correctly, of course. But that's how you do it. So we'll do a few more together. So we want to see if x plus 2 is a factor of this quadratic trinomial, right? So to check if it's a factor, I can do synthetic division and see if my remainder is 0. So what am I going to put on the outside here? Good. And am I skipping any x's in my dividend? No. What's the coefficient of my x squared? Coefficient of the x? And? Very good. We're going to bring down the 1. We're going to multiply. That gives me -2. I add -8. And I multiply 16. Add, and I get -4. So the answer here would come out to be, yeah, the answer is no. This would come out to be 8. I'm just going to write the answer anyways, like what you would get. It'd be x minus 8 plus -4 over x plus 2. So we have a remainder, which means that it's not a factor. Not a factor. Any questions thus far? All right. So on the next one here, what's going to go on the outside of my synthetic division? -1. Am I skipping any b terms? No, I don't need a placeholder. So I'm taking the coefficients of each of these terms. So this is 1, -4, 1, and -2. I bring down the 1. I multiply. I add. Multiply. Add. And multiply. And add. What's my remainder come out to be? -8. How do we write the actual answer to this? What is it going to be? And then good. Oh, we shouldn't have x's here. My bad. This is b. I just realized that. We're using letter b, so just make it consistent. This would be your answer. And is the answer to the question no or yes? No. The answer would have been yes if the remainder was 0. Good? You guys getting it so far? All right. Yep. You're welcome. Okay. Moving on to the last U try. We're going to see if this is a factor. So we're going to do synthetic division. Just going to do it quickly here. So this is 1, -8, -5, 4, 40, and -3. So the answer here is no, right? And this would come out to be x minus 5 minus 3 over x plus 8 would be our answer. Now, could I also have done this using long division? I'm going to do it with long division just because I know you all have to work on that homework and I want to make sure you guys remember how to do it. So I'm also going to do this with long division. So just to refresh your memory, that would be x plus 8, and then on the inside, that would be x squared plus 3x minus 43. I didn't have to put any placeholder terms in. What would I multiply x by to get to x squared? X. X times x plus 8 is x squared plus 8x. I subtract this. This becomes 0 minus 5x. I bring down the 43. I erase the 0. What would I multiply x by to get to negative 5x? Negative 5. I multiply all of this by negative 5, which gives me negative 5x minus 40. This is a negative. I'm subtracting, so these both become addition. I combine. This is 0 minus 3. This is my remainder, right? So my answer would come out to be the same. X minus 5 plus, or minus, in this case, my remainder over my divisor. So I just wanted to show you with long division how we get the same answer. Synthetic division is obviously the faster and easier route, but just keep practicing your long division too, because there's going to be problems that require you to use it. So do you guys have any questions for me on this lesson? Okay, this lesson for you guys, since you're doing it on a Friday, will be due, hang on, let me see.